Hey guys, today we're taking a look at two lines cut by a transversal and the angles that are formed by that transversal and those two lines. Specifically, we're going to take a look at the facts or the theorems when we have two lines that are parallel to each other that are cut by this transversal. So in our little diagram here, you can see that we have this yellow line AB and the blue line CD that are intersecting. So right now they're not parallel to each other. However, we can move these points around to form two lines that are parallel. Now, line AB and line CD have the same slope, so they'll never intersect, so they are parallel to each other. And here's our transversal. Now, when we go to look at our 8 angles that are formed, remember these 8 angles have specific names. They're either corresponding angles, alternating interior angles, alternating exterior, or same side interior. Well, there's some interesting facts that arise of these angle measures when we have lines that are parallel cut by a transversal. So let's turn those angle measures on now, and you can start to see how this top grouping has angle measures that are all equal to this bottom grouping. Now we're going to go over to our notes for today and take a look at some of these theorems or truths. Here's what our first truth says. It says if two parallel lines are cut by a transversal, which is the situation we just had, then our pairs of corresponding angles are congruent. So the way we abbreviate that is we say if two parallel lines, and then we use the word then, corresponding angles are congruent. So we'll abbreviate angles and we'll abbreviate congruent. So take a look here in my diagram. You see that this line L here and line S that are being cut by this transversal line T are parallel. Line L and S are parallel to each other because of the arrows. And we see that this angle here is 67 degrees. Angle 1 is in its corresponding location. Therefore, we can conclude that angle 1 is also 67 degrees. Now, just to be sure of that, let's go back to our diagram here. And what we're going to do is we're going to turn these angles off. We're going to show you corresponding angle pairs. So again, you can see red corresponds to red, blue to blue, yellow to yellow, and gray to gray. Now, we're going to turn on our angle measures here, just so you can see. Red is 79, so is this red up here. This blue is 101, and so is this blue down here. And no matter where I move my transversal so that it cuts through those two parallel lines, those corresponding angles are always going to be congruent to each other. So again, here you see red is 102.7, and so is this red up here. So when I have parallel lines, my corresponding angles will be congruent to each other. Now, let's make my lines so that they're not parallel. Here you can see that my lines intersect. And what do you notice about my red angles? 88.2 and the other one is 107.1. They are no longer congruent to each other. We're going to bring these guys back to the fact that they're parallel, and we can see that they again are congruent to each other. All right, let's take a look at our next theorem or our next truth about two lines that are parallel and cut by a transversal. The next one says our alternating interior angles, if two parallel lines are cut by a transversal, then our alternating interior angles will also be congruent. So the way we'll abbreviate that is we'll say if two parallel lines, then alternating interior angles, AIA, are congruent. So in this example over here, you can see that our lines P and Q are parallel to each other because of our arrows. Our transversal line R cuts through them, forming these two angles that are alternating interior. Well, I know that they must be congruent to each other because my lines are parallel, and therefore I can say A plus 28 is equal to 2A. I can subtract A from both sides, and I'll have A is equal to 28. So I can find the value of my variable A, and I can substitute that back in to find the measure of angle PNM. That would be 28 plus 28, which gives me 56 degrees. Therefore, our alternating interior angles will also be congruent to each other. Now, just to show that to you, we're going to uncheck our corresponding angles, and we're going to put a check on our alternating interior angles. So you can see here, here's a pair of alternating interior angles. And again, anywhere I move this transversal, I'll see that those two angles are going to be congruent to each other. When I turn it back on, those highlighted pairs of angles are congruent. As I move this around, you can see that these angles continue to stay congruent to each other. All right, let's go on to our next truth or theorem about parallel lines. Our next one says alternating exterior angles, and this one's abbreviated as if two parallel lines, then alternating, oops, I forgot my N, exterior angles are congruent. So as you read through that, you see the same thing is true for alternating exterior angles as they were for alternating interior. So again, over here in our diagram, you see that we have these two parallel lines coming through because of the arrows on them. And this angle measure X here and this 138 are alternating exterior angles, and therefore they must be congruent to each other. So angle RST must also be 138 degrees. All right, finally here, our next theorem, it says same side interior angles. Now, this is the one that's different. So read through this carefully. It says if two parallel lines are cut by a transversal, then same side interior angles are supplementary. So we'll abbreviate that as if two parallel lines, then same side interior angles are supplementary. Now remember, supplementary means that they add up to equal 180 degrees. So in our diagram over here on the right, you see that we have our two parallel lines coming through here. You got the arrow notation indicating that they're parallel. This angle here is 133 degrees, and this angle 1 is on the same side of the transversal and on the interior. So I know 133 degrees plus this angle 1 have to add up to equal 180 degrees. So angle 1 can be found by taking 180 and subtracting 133. And this gives us 47 degrees. Now, again, just to prove our point, let's go back to our sketch over here. We're going to turn off our alternating interior, and let's show you what our alternating exterior looks like. Those are the ones on the outside of our parallel lines and opposite sides of the transversal. Now, if I turn my angle measures back on, you'll see that they're both equal to 67.9 degrees. And that remains true no matter where I move my transversal. No matter where I move my parallel lines, as long as they're staying parallel to each other, those angles will be congruent to each other. Now let's try our same side interior. So remember here, our same side interior angles are in between our parallel lines, and they are on the same side of the transversal. So if I show my angle measures now, you'll see that these guys are actually not congruent to each other, but they are supplementary. Let's see if I can get that exactly. Ooh, right on. So 104.9 and 75.1, those guys add up to equal 180. So these are some of the truths about parallel lines that are cut by a transversal. Let's see if we can put our newfound facts into some problem-solving techniques here. Example 1 says find the missing angle measure and write the theorem or the postulate that gives the reason for the following statements. All right, in our first drawing here, we'll call this drawing A. I see that I have these two parallel lines. Here's my arrows indicating that they're parallel to each other. And these angles are on the exterior of the parallel lines, and they're on opposite sides. So I know angle FHD has to be equal to 58 degrees because of the alternating exterior angle theorem. All right, next up here we see in drawing B, I have again two parallel lines. Now these angles that I'm looking for are on the same side of the transversal, which is our blue line, and they're on the interior. So I know that same side interior angles are supplementary. They add up to equal 180. Therefore, I'm going to take 180 and subtract my one angle that I know, which is 62 degrees, and I'll get the remaining amount of 118 degrees. Therefore, angle HGB is 118, and that's by the same side interior angle theorem. All right, last up, we got these two parallel lines here. This is drawing C. These two parallel lines because of the angles, or because of the arrows, and I want to find this blue angle right up here in this corner, and I see that its corresponding angle is 99 degrees. Therefore, this blue angle, HGB, must also be 99 degrees because of the corresponding angle theorem. So I'm just going to abbreviate that here in